Our first question is looking at a sequence and series question, specifically an arithmetic series. So have a read of the question there, and we have a formula on the side as well. So it gives us that the fifth term is 16 and the 100th term is 301. This indicates that we'll use our formula above, the nth term it's called, and also find the sum of the first 50 terms after that. So a plus bracket n minus 1 close bracket times d, n minus 1 in this case is 5 minus 1 is 4. It's equal to 16. Do the same for the second. 99d equals 301. We've got two equations, two unknowns, so we're going to use a simultaneous equation through elimination. 95g equals 285, and that divides in fairly nicely, I believe. Yeah, d equals 3, one of our values. Now we have to find a. Just substitute in your d value and we should find a. No problem. We plug it into our first equation. It doesn't matter which one you pick. So a is 4 and d is 3. From there, we have enough details to do our sum. So find the sum of the first 50 terms. So in this case, 50 is n. And again, 49 was our 50 minus 1, n minus 1. Plug down your calculator, that's your answer. So it's not exactly a very expansive question, but you do need to know what you're doing and you do need to be able to start. So by start, I mean literally figure out what needs to be done. Question 2, a particle P is moving. And as you check through it, we have some details, a restriction or a boundary, and we have V is equal to T squared minus 3T plus 4. And we're looking for acceleration in one part and displacement in another. So if going from velocity to acceleration or displacement, we immediately know that we need to use differentiation or integration. Displacement is s, velocity is v, and acceleration is a. And in that direction, you would look at it in terms of differentiating, and going the other way, we would integrate. And you need to remember that you need to learn it off by heart. I would learn one way. I mean, you just practice a bunch of questions and you'll remember it anyway, but try and remember one specific route. And of course, the other one is anti-differentiation, for instance. The other one is the opposite. So let's do out our acceleration now. First part. Part A, find an expression for A in terms of t. dy over dx is our notation for differentiation. And again, looking at our formula on the right hand side, 2 times t is t, 2 minus 1 is 1. So 2t to the power of 1 is the same as 2t, and and minus 3t, our t disappears. We have just a constant of minus 3. That's the first part done. Integration. The notation that you see, there's actually a few variations, but you should always put out the notation exactly the way it's done out. the dx, for instance, always has to follow at the end until the point where we're just now integrating. Again, integration is, you can see on the right hand side, the formula so x to the n plus 1 over n plus 1 plus our constant of c. And we're given more details from a point of 7 meters where t would be 2, and then there's another part as well where we delve in further where t is equal to 4. So just figuring it out there, putting your t is 2, and it looks like we're going to solve for c, doesn't it? Because our displacement is in fact 7. So get your calculator out and do that, and you'll find the value of c. So there's not much to do next after this. C is equal to 7 over 3. So now we have c as part of the equation, and we're going to plug in or substitute t for 4. And after you've done that, you should find an exact value for your displacement. So rewrite this out. 1/3, so 4 is the power of 3. 3 over 2, that's 4 squared. Plus 4 times 4 plus 7 over 3. Again, your calculator will do the bulk of the work for this. And their exact value is 47 over 3. Now we'll just check the marks. 1, 2, so 1 there. 3, 4, yeah. That's 5 altogether, so 1 for C and 1 for the final answer. There's your 5 marks there, with the 2 for the expression and acceleration as well.